Good morning, everyone. Thanks for being here. Looks like we have a disproportionate number of people on this side. You feel like you're going to get more IoT over there than you would over here. Maybe. I don't know. Anyway, my name is Rob Tiffany. I'm the Global Technology Lead for our Azure IoT business at Microsoft. That's a mouthful. So that's where I'm spending all my time. We're building a great IoT kind of middleware stack, and I'm going to walk through all of that with you today. I'm going to actually, as the title says, I'm going to mash up a bunch of things. Obviously, IoT device, we'll start with a Pi. Has anyone gotten to play with Windows 10 IoT Core yet? Excellent, a few of you. It's free. Just download it and start. It's really easy to get set up. If you've anybody play with a Raspberry Pi or any other do single board programming or anything like that? Excellent. Okay. So you might be used to doing things with different variations of Linux, embedded Linux, or other maybe real-time operating systems. Anyway, we're going to have Windows on there now, and so I'll show you a little bit of that, and I'm just going to take you from end to end, right from the device all the way through our server stack and to the output, because that's kind of a lot of what it's all about. Inputs, analysis, and the output, the value of IoT. What's the whole point of doing all this, right? It's the data. So we only have an hour, and I've got a lot of demos. And actually, I'll as I walk through each step at the beginning, I'll kind of talk about it a little bit, kind of do a little demo just to give you some awareness. I definitely have too many instances of Visual Studio running for safety, and I've heard all about the New Zealand internet, and of course, all my Azure instances are in the western United States, east of the mountains from Seattle. So I'm sure it'll be really responsive. Anyway, let's just dive into it. Oh, and it's also the very end. I'll spend at the very end kind of walking through scenarios for you. So I want to make sure you get information on everything and make sure you see some code, because that's why you're here. But then I think one of the most important things to take away when you're talking about IoT is really brainstorming all those great scenarios. How are you going to use this? Or how are you going to add value to your business? If it's your business and you want to add value, or if you're a consultant working and you want to help your customers, things like that. I'm going to definitely walk you through some real concrete kind of scenarios, examples that you can take home with you, because that's definitely where the value is. So it's almost like I already said this stuff. Yes, I'm going to tell you. I'm going to be like. Remember all those books you read where you start off the book and it says, let me teach you about the beginning of the internet, and they waste a whole chapter on that. So I'll do that here with the Internet of Things. Talk about Windows 10 IoT Core, walk through Azure IoT services, and then I'll wrap up with a bunch of scenarios that you can take back with you. And again, while it's fun to write code, the scenarios are actually the most important thing, So let's dive into it. Here's your obligatory, wow, 5 years ago, look what IoT looked like. It was silly. We just did, did we really do refrigerator stuff back then? I don't know. We certainly did vending. I got my start when my first startup I ever worked for back in '94, so I'm really old, we didn't have the word IoT back then, but it was vending machines. People love to talk about vending machines as the poster child for IoT, or they talk about Nest or things like that. I literally was at a company where it was vending machines, and vending machines were not advanced. They were fully mechanical, and you put in quarters. But we built a company because of the advent of wireless cellular data. It was a new thing, wasn't great. And then building our own firmware and retrofitting old vending machines to figure out what kind of information can we get on how much inventory, how much money has this thing been making, how can we make route drivers more efficient for deploying that. It was really hard to do back then. And so it's funny for me today. It's great because everybody I talk to, when I hear about IoT, they tell me about their great new vending machine idea. And it's certainly a lot easier today than it was then. So today's just kind of crazy on steroids with IoT. It's being bolted into everything. Some things, a lot of times there's like the internet of silly things where, I don't know if anybody's familiar with the Gartner hype cycle. Anyway, IoT is at the top of the Gartner hype cycle. So if you want to go make some money, do an IoT startup right now. Go get yourself go to Silicon Valley and get yourself some fat financing from venture capitalists, and then sell out really quickly. Because you know what comes after the hype cycle at the top is this trough of disillusionment, as it's called, and then things will come back up again when reality sets in. But right now there'll be lots of crazy things. Not all these scenarios are going to make it. I think it's important for you all to play with these scenarios. Work with these small devices, get involved with all the wireless technologies that are enabling this stuff today, and build some of these silly things. But the things that are probably going to make it are the things where there's real money behind them, right? So all those IoT toasters, they may not survive the trough of disillusionment, but heavy industry that's been doing machine-to-machine for decades, and they take advantage of some new things that we're doing with analytics and stuff, those are the things that are going to last. Anyway, it's a fun space. So kind of three different disruptive forces. We love to talk about disruption at these things. So everybody knows about Moore's laws and increasing the density of transistors every 18 months. You probably know Bob Metcalfe. He did 3Com, and his law was, the more nodes you add to a network, the more value there is to a network. Marketers use that stuff too also. They call network effects and things like that. One you may not have ever heard of is an obscure one called Kumi's law, because we have no shortage of laws. We saw some rules and laws at the keynote last night too, didn't we? So this one's important for all of us on the IoT side. And basically it's just saying, look how many more computations we're able to do as the years have gone on with the same amount of power. And so we're getting more and more efficient. This is a big deal in IoT, because you may be building lots of tiny little sensors and MCU, little controllers and stuff that need to last for a long time, maybe years, and do their job without you going and replacing batteries. Or it may not be able to be plugged in. It might need to work off a watch battery or something, or solar, or who knows. So this is super important. So what is it? So obviously there's those things. So people ask, why is IoT a big deal now? Why are we talking about it so much in the last couple of years? Why is it all hyped out? Because depending on who I talk to, again, if you've been doing SCADA systems and machine-to-machine, you and big companies, you've been doing this for decades. And so big companies could buy jet aircraft engines that send gigabytes of telemetry off the engine to tell you how things are running. And they also sell you the back-end analytics and the dashboards and the whole NASA mission control thing. And it's kind of an end-to-end solution. And that was something that big companies with a lot of money could buy. Think of IoT as the democratization of all of that. The cost of compute has dropped so dramatically. We have these little tiny ARM Cortex processors that cost almost nothing. I'll use the term ubiquitous loosely, but more ubiquitous wireless. It's more pervasive everywhere. That's coming together. Being able to run off of small batteries for a long time. A lot of innovations have come together to make this more viable for everyone, and not just companies with lots of money who can, when they build factories with big machinery, they can buy kind of machine-to-machine instrumented machinery and do that. It's for everybody now. So everybody gets to play, which is great. So we know what the things are. Then there's connectivity. Connectivity is a big deal. When I got in this business 20 years ago, that was what made the difference, was wireless. It really was. And wireless was so tough back then. But it taught me a lot, like we had to pay by the byte. Lots of people have gone through an age, I don't know if you remember like the beginning of the 2000s, when we had the big SOAP and XML revolution and SOA, and everybody was going to do that, and it turns out not everybody did it. But everybody learned a lot of bad practices around writing bloated wire protocols that waste lots of bandwidth and goes really slowly. But it was easy because we were back in I'm connected to Ethernet, and who cares? It all just works. Well, luckily, in my head, I'd started in a time where we had to bit encode everything and create our own tiny packets because we had to pay by the byte, and bandwidth was all narrowband. It was dismal. And luckily, that stuck with me. So it's good to kind of try to go back, or if you don't have those skills, learn about, I know it sounds really geeky, but that's why we're at this conference, because we're a bunch of geeks. Learn about the importance of wire protocols, because they absolutely matter. And I'm going to walk you through a few of them, whether you like it or not. Data. In the end, this is all about data. There is some value in getting data from all the telemetry coming from all these sensors, all these things that are in your environment. whether it's telematics coming from fleets of trucks, the HVAC systems, keeping, cooling, or heating these buildings, all the lighting, things like that. You probably heard things like smart cities, smart buildings, smart everything, right? But it's all about the data. What is the value I'm going to glean from this data? That's why we're doing this. It's not a science experiment for fun, but it's kind of fun. And then, of course, the analytics. We apply analytics to all this data that we're getting that we didn't necessarily have before. And that analytics is going to tell us something. It's going to say, oh, I noticed that such and such was happening. You saw a lot of this last night if you were at the keynote. There was a lot of talk about applying analytics to business and how you can see, and a lot of it was actually seemed almost like customer-facing stuff, behavior of customers, things like that. But you can apply this to anything, and that's the real value in all this. And I'm going to dive into all this stuff. So let's geek out a little bit about radio protocols. I won't spend too much time on this, and everybody knows about Wi-Fi, and you probably know about Bluetooth for years. And in the last few years, we've had this Bluetooth Low Energy. Actually, a bunch of my friends I worked with, I've been at Microsoft for a while and used to work in the Windows Mobile division. And believe it or not, a bunch of my friends are actually working at the Bluetooth SIG, which is just a few miles from Microsoft, and driving all those specs. So Bluetooth LE is low energy so that it could run on your device without using a lot of battery power and have things. Anybody heard of beacons? Beacons are pretty cool. They're slowly but surely. We thought this last Christmas they were going to be a big blowout hit in retail, and they weren't. Maybe next time. Maybe they will this time. I don't know. But anyway, the retailers are all excited about beacons, and they send out a little advertisement, like a GUID to you. Anyway, but they're all low energy so that those beacons can last a long time, and that's going to be interesting for retail. Things like Zigbee, Z-Wave, Thread, they're all based on similar radio protocol. And basically, you see them certainly in a lot of in-home things, in-home home automation systems. Instead of Wi-Fi, but you could use Wi-Fi. They just don't need as much energy to run, so they don't, Wi-Fi uses more energy than anything, and so that's only going to work for you if it's plugged in. Everything else, you got to really care about it. So you see those three around, and they kind of do some cool mesh stuff. You're also seeing there's a 6LoWPAN. There's all kinds of weird acronyms out there where you have mesh networking. You maybe have seen some Internet of Things light bulbs where you can plug in, and then they all daisy chain and mesh and talk to each other and send data about how bright they are. Maybe you can make them blue or something like that. We'll see how well those survive the trough of disillusionment. But then there's other things, like in smart cities, which I'll go through a scenario at the end, where this can happen out in cities, and you'll be able to use this mesh networking to your advantage. The two that are most interesting to me that you may never have heard of, this LoRaWAN and Sigfox. Sigfox is what really kicked this off. They're a company in France. They are using ultra-narrowband technology in this unlicensed space of wireless that governments, the EU and US have set up. And so it's not everywhere. But they're able to play ball around some emergency frequencies, some other things. And when I say narrowband, we're talking bytes. Sigfox, you send little packets of maybe no more than 12 bytes each time. And lots of people go, oh, I can't imagine. How could I make something be only 12 bytes? I need big XML and stuff like that. So you need to learn about this stuff. This is important. But it turns out if you're really smart and you know how to build efficient things, you can get all the data you need. There's ways to encode all this stuff to get it small. So Sigfox, long range, we're talking 10 kilometers. But really slow, not very fast, but you send less data, but it still does the job. And very low power. We're talking sensors on this power, and then equivalent, and there's base stations that go along with this. But we're talking things that can last for years on battery using Sigfox. And so a good example, so we all know what mobile operators are, carriers, and they put cellular towers everywhere and do the hex thing, and that's how you have coverage across your country. Imagine a technology where you can use a fraction of the number of towers. You just build these simple base stations that can go 10 or 15 miles, things like that. Parallel mobile networks for IoT are being constructed right now. All of France is covered by Sigfox. All of Spain is. I think the Netherlands are getting it. They're spreading around. You could do it here. You could cover Auckland with maybe 3 or 4, maybe 5 of these cheap base stations. and build your own parallel shadow network, without having to play ball with the mobile operators. So it's really interesting. LoRaWAN is similar to a Sigfox. I'm not going to say either of them is a standard because they're not really. Sigfox is doing their own thing. LoRaWAN's kind of got a consortium of folks to go out. It started in Europe, but really similar stuff. Keep an eye on that. I know this sounds really obscure. Not everybody's into wireless like I am, but these last two things on the end are super disruptive, just super disruptive. Wire protocols. So wire protocols, while you see some of this data going into IoT middleware systems like ours or others. So is anyone an Azure person in here? A couple of people? Wow, I was hoping all hands would go up. Wow, one tier. All right, so in Azure, we have something called Service Bus. And then we have something I'm going to talk about called Event Hub for high volume data ingestion. Because all these analysts that you read about are telling us that there's going to be 50 billion or whatever, some crazy number of devices out there. And so luckily Microsoft has built a system to accommodate a ridiculous number of things. But part of it is wire protocols, like I mentioned earlier. So we use something called Advanced Message Queuing Protocol. It's really efficient. It was actually born on Wall Street. All the evil high-frequency traders who are messing with stock trades use it. So if it's good enough for them, it's probably good enough for IoT. Probably the most popular one, and again, a lot of these are what I would call M2M protocols, machine to machine. So they've been around a while. MQTT is probably the most popular one. It was originally created by IBM. Notice the MQ part makes you think of MQ series. Anyway, they donated that to Oasis. That's the most widely used one. CoAP. When I talk about all those mesh network things, maybe out in the streets and smart cities, it's kind of like REST, but it's really small. Take a look at that. OMA, LW, M2M. So you know what, maybe you don't know what OMA DM is. That's how we are able to do device management on Windows and Android and iOS devices. So imagine we need a standard for doing device management for the Internet of Things, right? It's going to be a whole lot harder because it's hard enough. It took years to get standardization around 3 different platforms for mobile devices. Now we're talking about N number of Internet of Things running a very zillion different operating systems. So it's not trivial, but this is something to look at. And you may have heard of XMPP. It was, remember Jabber, chat, stuff like that. These guys are trying to play too. Of course, it's got XML in it, so I just don't see how that can be a great solution in this stuff. I talk about Azure and I'll go through the stack we're building. And you talk about the big mega numbers of devices, of things that analysts talk about. And that's why building our system that we built in the cloud is so important. There are absolutely lots of competitors and lots of great products out there in the IoT space and IoT middleware and everywhere, the on-premise solutions. And the problem is, though, they will run out of gas. They can only handle so many devices. So we not only build a system that can handle tons of devices, millions of devices, but all over the world, all over the place. So we have more regions of data centers than Amazon or Google does. And we're talking millions of servers here. So you making a bet on our platform for IoT telemetry is a safe bet, or it's not one that maybe it'll work for you for the first 10,000 and the 100,000, but then, oh gosh, it's not working anymore, it can't scale, or it's not fast enough, or I can't take care of my customers all over the planet. You're not going to have that problem with us. So I'm going to walk you just from end to end. Let's start with the device side of things, and then we'll walk you through the server side. So let's talk about Windows IoT Core. So it's a small mini-me version of Windows 10 that can run on ARM and x86 devices. And you can see a few here. Raspberry Pi is probably the most popular device out there. It's designed for education, actually, to help teach kids in the UK, get them started doing stuff with programming and doing hardware and learning how to solder stuff and things like that. And it's because one of the guys who started it works for Broadcom. And so it kind of made sense. Hey, let's build a single board computer. Intel's got something called the Minnowboard Max that's running their Atom processor. And then Qualcomm's got this Snapdragon 410-based device. It's called the Dragon Board, actually. Mine's still on order. I still haven't gotten it yet. It's more similar to the Raspberry Pi, except it's faster, and it has a lot of the wireless stuff built into it. So it has GPS and Wi-Fi and Bluetooth LE and all that stuff baked into it. So these are fun. These are also, though, if anybody who's really, really in this space, like one guy I know in this room, these are large devices in the big scheme of things. They're giant devices. There are many, many tinier, smaller memory, energy-efficient devices out there that will actually be deployed in lots of smart city and other situations. These are really big devices. You can absolutely use them, but they're not cost effective if you were going to try to ship a toaster with a Raspberry Pi glued to the side of it, whatever. It's too big. But these are good things. Not that you know anything about field gateways or stuff like that. I'd say these are a great size device to build field gateways. In this world of machine to machine, like if you're in a factory and you have tens of thousands of sensors sending telemetry, even though you hear people all the time say, oh, we got IPv6 and everything is going to have its own IP address and they're all going to talk to the cloud. That's really not what's happening. What happens is inside that factory, those 10,000 things talk to a field gateway that's an edge appliance. Think of it as like a router, that you probably already have in your company. And it makes intelligent decisions about what to send on to the cloud, or maybe does some analytics there. These size devices are a good size to build field gateways, actually. AllJoin is something, that's a consortium we're with Qualcomm. And so you'll probably hear more and more about AllJoin. This is All-Seen Alliance that we're in. And so there's all these AllJoin interfaces. And actually, when you download Windows 10 IoT Core today, there's lots of examples how you can do AllJoin. Think of it, remember when Plug and Play came out a million years ago and then Universal Plug and Play? Think of it like that. It's a way of devices to discover each other. Because a lot of times when I talk about IoT, especially from device to Azure, it sounds very hub and spoke. What this does is it allows you kind of more peer-to-peer. It'll let sensors communicate with each other securely and discover their capabilities and things like that. And so pretty cool stuff. There's no UI on Windows 10 Core, and then when you want to talk to it, you can use SSH, and I'll show you here in a second. You can view it from the web, as long as you're all connected on the same network. Obviously, since 100% of you are developers here, you're excited about you can build apps using, you've probably heard about the Universal Windows Platform apps. And so, pick your favorite language, and you can use it in Visual Studio to build apps for it, which is great, because a lot of times in the past, IoT has been the domain of, M2M. It's mostly C, tiny things, right? So you need a tiny language, right? That gets small and is super efficient. And so, but again, we're democratizing that a bunch here. And also, we're supporting Node and Python in Visual Studio as well, so you can absolutely use that. And so if you have that familiarity or comfort level, or if the developers you work with in your company or consulting firms you work with have those skills, it's great. You can leverage those skills in IoT now. So it's good stuff. And then we've got all kinds of templates. So let me quickly show you. I'll just kind of do a quick lap around here. So the first thing I'll show you, just to see it, let's see here. Let's turn on the Elmo. So here's my Raspberry Pi 2, which is important. Raspberry Pi 2 came out this last year, and it's 6 times faster than the original Raspberry Pi B+, or whatever, which is important. It's quad core. So anyway, as you can see here, it's got 4 different USB ports. So if I plugged in a keyboard and a mouse, it's got Ethernet, which I'm using Ethernet to give me all the help I can get on the New Zealand internet. We've got HDMI going out there, and I have that. And I'll show you that in a second. When it boots, you boot it up just by plugging in the power. So you can see right next to there at the very end on that corner, we power it up that way. And then it just runs one app at a time. And I'll kind of flip it over here. And you can see on the bottom, you see I've got an micro SD card. So the operating system is on the SD card and all storage and everything you're ever going to do. That's your hard drive. Now, there'll be other single board stuff that'll have built-in flash and things like that, but with a Pi, that's how it works. If you were doing a Pi, when you buy it by default, it uses a version of Linux called Raspbian, and it works exactly the same way. It just boots off that. So there's a step. In fact, go to my blog, robtiffany.com. I've got 2 posts recently that will literally walk you step by step to flash your own little SD card and get yourself up and running with Windows 10 IoT Core. So that's kind of the look of things. And then let's flip over here. Let me let you see the Pi for real. So this is kind of what it looks like when it comes up. What this actually is, it's not to let you think that there's a real shell for it. This is actually an app. This is a universal Windows platform app. It's just called Device Default App or something like that. And so it comes up and it kind of gives you a little bit of information and lets, for people to get started. It's not showing everything because of the resolution here, but it shows you with some starter projects and kind of helps you get going along. Some minimal settings, and we're talking really minimal. Wi-Fi right now with Windows 10, the only Wi-Fi I think it works with is if you go to raspberrypi.org, the foundation, they actually sell a dongle. I think it's €6 or something, or £6 actually, is how much it costs. So pretty cheap, and that'll work by default with Windows 10. And so you can get up and running with Wi-Fi, so you're not having to use Ethernet like I am right now. So this is, so this is actually a universal app running, and it just runs one at a time. Or actually, it can run one UI app and then a background app. Lots of times when you build these things, you'll build something called a headless app. There's no GUI, so it makes sense to have a GUI, right? So I'll quickly go back to my laptop here, and let's just fire up Visual Studio. I'm not going to do anything right now yet, but just so I have an idea, just real quickie. Like when you go from file new project, what does that look like? How do I get started with that? And so if I just go in Visual Studio and just say new project, the kind of two big options that you have for you if you look in there, and I apologize, it probably might look a little small, but you see Windows Universal, and there's blank app right there. And I'll show you I built just a simple vending machine app, but the great thing is, and you probably heard this ad nauseum in the keynote last night, is these universal apps are going to run everywhere. And so you'll run it, I'll run it on my desktop and as x86, and then you can switch to ARM. I'll show you that, and you can compile it for ARM and deploy it and run it on your Pi or your Xbox or HoloLens, stuff like that. That was kind of the gist behind the talk last night around these universal apps. So I can build a GUI app if I want to show a UI that way, and there's lots of reasons why you might want to do that. And then here you see I also have this template for Windows IoT Core, and this builds a background application. Has anyone ever built like an NT service? Excellent. Or a Unix daemon or a web role in Azure. So it's like that, and so it just it's probably going to be on a loop, or it might be blocking, and it's going to just sit there and wait for whatever needs to happen. So real simple to get up and running with this stuff here. So let's move along. Having to juggle like a zillion different buttons here. Woohoo. All right. So now let's jump into, now that we've covered kind of our slice of things, let's talk about Windows IoT services. Azure IoT services. This is just kind of a high level, kind of frame things for you. If you kind of follow it from left to right, devices, those are the things. We've been talking a lot about that so far. So whatever they are. Connectivity, and that's this thing called Event Hub I'm going to dive into, and that's where the data goes in to Azure at a high scale. You see you've got a lot of different storage options if you just want to store the data, send it to SQL or simple blobs, just if you're just going to save them serialize them as files or whatever. We do have NoSQL now. You can use table storage or you can use DocumentDB for those of you who love to do NoSQL, kind of like Mongo or Couch or whatever. Analytics is the meat of this stuff. So we're going to get some insight from that data, right? So I'm going to walk through several of these: machine learning, streaming analytics. And then there's the output. I got the data in, I did analytics, and now I got to show it. It told me something, and I need to display what it told me. And so we have a lot of ways to display those outputs, and I'll walk through a few of those. So even though I just showed you the whole Windows 10 IoT Core thing, a key thing on Azure IoT is that we want to play well with everybody. You've probably noticed that since Satya came in last year and a half or so, how Microsoft seems to be playing well with others and building stuff on other platforms. And that's same goes here with IoT. So we built these client libraries in C, and we're going to build on top of that, but to make sure they run everywhere, to run on all those different versions of embedded Linux, to run on these different real-time operating systems, so that our whole thing, we need to meet our customers where they already are. I don't want to force you into something or make things harder for you. I want to reduce the friction for you to play with our stuff. So these client libraries are going to run everywhere. And then we'll be building on top of those, because I know Node.js has gotten really popular, and we'll build on that. You can use Java, you can use whatever. But C was where we started. And of course, we have .NET libraries today, as well as Java libraries today that work everywhere. What these libraries will do is help you kind of shape the data that you're going to send and use this advanced message queuing protocol to send into our gateway, into Event Hub. And so we make it simple to do that, do it securely. And we have some data buffering, kind of offline stuff, in case your device is not connected at that given moment, if the connectivity is down or something like that. It's aware of that, and it'll buffer the telemetry it's going to send. So anyway, this is all to just speed up your time to market. You don't need any of this stuff to get playing today. Because remember, all we're talking about is wire protocols and following security models. You can do that yourself. This is just to try to make things easier and speed things up for you. So where's the data going? It's going into Event Hubs. Event Hub is derived from our Azure Service Bus technology. And so think of, like, have you ever done like database sharding, horizontally partitioned, shared nothing systems to build crazy scalable systems? So imagine that with queuing. And that's kind of what Event Hubs is. So the cool thing is millions of events per second. So imagine you've got all these millions of devices in your smart city. You've made Auckland or Christchurch fully smart enabled. You've instrumented everything to make it the best city for its citizens. And so, but you need to make sure you have something that can handle all that data. And that's exactly what Event Hub is designed to do, to handle all that data. And then we secure all this stuff with shared access security tokens. And I'll actually geek out with you and show you how that works a little bit. Why this is all important, lots of people talk about authenticating all these little devices. And lots of people say to me, well, why don't you just use Azure Active Directory? I'm like, well, you could. But at some point, the sheer scale and velocity and throughput far exceeds what we built yet. Azure AD is made for humans. And these devices are going to far outnumber humans by a large scale and the amount of data coming in. And so we needed to build something that, because can you imagine, I'm sending telemetry from a million things. Every time it's about to go in, it goes, oh, need to do a quick lookup against a directory and do auth. You can imagine how that can slow down. You can imagine in our normal world, you never notice that. But when you amplify it times 50 billion things all shooting data at the same time, it kind of causes a bottleneck, right? So we use these shared access security tokens to take care of that problem. And they're just a super efficient way to ensure that only the right data gets in. And furthermore, if devices are determined to have gone rogue on you or whatever, you can blacklist those devices and keep them from coming in. So let's look at some Event Hub stuff. So, nope, that's not where I wanted to go. Let me go back to my laptop. Okay, so I'm here. So for the handful of you who use Azure, hopefully this might look familiar. The Azure portal, it's our HTML5 portal. You do everything you need to do in Azure via the web, so it's real easy. So I'm in the Service Bus section here, and so I'm just going to kind of give you a quick walkthrough of Event Hub. So I click on Event Hubs here, and it's pretty simple to get set up. And to monitor, requests coming in of telemetry. And so the basic things you need to know, you create Event Hub. This is notion of how long messages are retained, because think of it as a queue, as a message queue, but it's just a queue on steroids. These shared access policies are how you enforce using these shared access signature tokens coming from the devices to enforce security. And what can they do? I can just send things in, or I can read things, so readers, writers, having a full administrative control. And then you create these keys, and then the key is used to derive a token. Think about it, it's like a claim, or people use tokens, when you do OAuth with REST JSON web APIs, right? So think of it kind of like that. And so that's how you handle security. But as you can see, it's pretty simple. There's not a lot to figure out to build this high scale. And then consumer groups is kind of the output side. I've created something called vending group. This is, readers of this data coming into this queue are going to go through a consumer group. So let's take a look here if I want to do something, let's just go to Visual Studio. And so let's just show my Raspberry Pi solution here. So, when you look right at top, again, it's really small, but the key thing I want you to take away, kind of see where my mouse is. Right now it's a universal app and it's set for x86 and local machine. And I absolutely can switch that to ARM and then deploy it and debug it remotely on the Pi and deploy it and get it out there. It's just that simple. I'm not going to debug it that way because it's really slow. So I'll show you I'll show you the local version, but make no mistake, it is the exact same app. The other cool thing here, when you're running your Pi and you got it on the same network, there's this Windows IoT Core watcher here that you can use, and so it can detect and says, yeah, I see your Pi over here. It's called House of Pi. And I can right-click on that, and it lets me do some interesting things. If I need to administer or look at Windows 10, makes it easy to deploy Apexes out there and certificates. In fact, a lot of this will remind you of the task manager in Windows. I'm seeing all the processes running remotely on my Pi here, and even performance, CPU and stuff. So a lot of the stuff you're used to having on your desktop in Windows through Task Manager, you absolutely have here as well. So if I run, I'll go ahead and run my little vending machine. So it's pretty simple. It's just I'm selling some different snacks. So maybe I'll just say, yeah, I've sold that, I've got 9 in inventory on candy, 6 left in trail mix, 4 not 45. We'll just say 4 and whatever. We'll leave cash alone. And so I'm going to just run it and not debug it at first time because it's going to fail, and then I'll kind of talk to why it's important that it did fail. This goes back to shared access security tokens. So it was unauthorized. So it had all the right information, but one of the other cool things about our security tokens is there's an expiration time, so that you can, if you don't want them to last forever, they absolutely don't. And you want each device to have its own token. So I'm going to run just a quick token generator. And so all these values you see in this little WinForms app actually are kind of pointing to my Event Hub. The name of the Event Hub, that policy, you saw me have those security policies and that big key. And so I'm just going to create a SAS token for it. And I'm just going to paste it into my other app. So I'm going to put it back here, right here in the SAS token in my Raspberry Pi vending machine. So I'll paste that in. And then let's run it again. And we'll walk through the debugging a little bit. The key stuff I want you to get from this is how simple it is. So this vending machine, basically all the UI stuff maps to, I just created a vending machine class. The device ID, you see I've got, 4 different types of products there. What's the name, what's the quantity, how much cash. So you just basically build the .NET class. It's really simple. And that class gets serialized as JSON, and then it will get turned into AMQP. So I'm going to click Send, and then we'll just kind of step through the debugger here. And again, I'm doing this on my local machine rather than over the network to the Pi, because the Pi is significantly slower. And we're already 37 minutes into this session, and so we can't take too much time. But the key takeaway here is it's going to builds that JSON-looking string right there that you're going to send in. And then it's gonna post this data. Another key thing you could take away from here is how, yes, you could absolutely build these things without needing any libraries. Because again, I'm sending this, in this case, I'm just doing REST and JSON. I'm not even using an AMQP library. And so anyway, that's sent off to Event Hub, and then we'll get back to where that's going to go and what it's going to do in a little bit here. So let's go back. So stream analytics. I'm going to walk through this in a second. So you know what a database is. You know that oftentimes you insert data into tables in a database, and then you run queries against it to find out stuff that's value to your business. So imagine a system that's designed to do queries against data that's streaming in real time and not waiting until you insert it somewhere. So it's data in motion instead of data at rest. That's what our Azure Stream Analytics is. And so if you know SQL, if you know how to do SQL and write SQL queries, you can absolutely use this product. And so you see me sending that telemetry in from my vending machine, and it goes into Event Hub. Well, Stream Analytics is going to pull it right from there. And I'll walk you through what that looks like here. So if I go back over here to Stream, let's scroll down and find it. There we go, Stream Analytics. So basically, Stream Analytics, there's three main things you have to worry about to get going with that, is these inputs, the query, and the outputs. So the input I set as a stream data, and it's pointing at my Event Hub. So that makes it simple. The output, in this case for the demo we're doing today, is I want to send it to an Azure SQL database. So I'm not going to do anything magical. I'm just going to grab that data and put it into a table in Azure SQL database. But this could be any other output you can imagine. And then I got it just a super simple query here. But as you can see, if you have any SQL experience, whatever you can write in SQL, you can do here in Stream Analytics. And so I'm basically doing nothing more than a select star. But you can imagine building the most complex queries to derive value. You know, if temperatures are out of band, or if things are out of stock and I need to alert someone or whatever, you can absolutely do this in SQL in Stream Analytics. And then you run these jobs. And so SQL skills are totally applicable, and you can get up and running doing the streaming stuff today without having to do programming. But you might want to do programming. And we just did the demo. So if you want to write some code on how to process this data on the back end, maybe you already have code that you're doing to do event processing of some kind, or just data ingestion, and maybe you've got some domain-specific language stuff you've built for your business, and you want to reuse it. We have some .NET code called Event Processor Host. It's just a library, and it also talks to Event Hub, just like Stream Analytics did, except that it's using .NET. And so if you're a .NET developer, or if you have .NET developers who you work with or on staff or at a consulting firm, they can use their skills to pull stuff. And remember I told you how Event Hub is sharded, has all these partitions, but you don't have to worry about it? What's cool about this Event Processor Host, it runs as remember I called a term called a worker role in Azure. It's like an NT service. It's running in the background. So it runs like that, but it automatically creates separate instances of itself on the fly to match all the sharded partitions. So it's designed for crazy scale. So Event Hub is taking everything it can handle, and both Stream Analytics and Event Processor can suck out just as fast as Event Hub can take in. And so you can run your processing against that using programming skills. And so let's do a quick take a look at that. So I had just sent some data in, and so here is some code. I called it Event Consumer. And so I built a worker role that's like an NT service, and then I have this code here. I'm just gonna run it, and let's see if it catches anything, you know, if it goes through the data, because ultimately you're going to have this async process event. The basic thing I want you to take away from here is as messages come in, there's a for each loop where it goes through these messages, and then you're going to decode it. Notice here, I'll deserialize that vending machine object and rehydrate it as an object you can work with. And then later on, you can do whatever you want to do with it. And so in my case, I could take that data and I could do, if you know ADO.NET, you can do queries and insert it into a table. You can also use some of our app services. And so it's really that simple. That's all the code you have to worry about to do that. And so if you've got lots of custom code that you're using, you can absolutely use that. And so that's how that runs, you know. And so, you know, ultimately you just send it on its way to, you know, it's really slow to refresh this stuff. But whether it's coming from Stream Analytics or whatever, you know, you can send it off into Azure SQL databases or wherever you want to go to do your different outputs. So I'm going to race through a few more here that are super important. So Azure Machine Learning. So, you know, I think like a lot of things in life, you have the 80-20 rule. I think probably 80% of the time you'll either use stream analytics or maybe your own code. You're just looking for out-of-band, detection, things like that. Oh, the temperature's too high or whatever, I need to do something. But sometimes you've got to do some serious stuff here. Has everybody changed their title to data scientist yet? I see lots of people doing that. They think they're going to get a pay raise. Anyway, if you're a PhD statistician, then yes, you're a data scientist. Anyway, and a lot of them use this programming language they love called R, like the letter R. It's hard stuff. So last night, during the keynote, we kind of walked through machine learning and the value of that. But also back to the word, like democratizing something that's really hard, because not everybody knows R, not everybody's a data scientist. How do we make this accessible to lots of people? So Machine Learning Studio, again, it's yet another, it's in the Azure portal, it's just another HTML5 site. It lets you drag and drop workflows with out of the box, was it either 200 or 300 experiments already pre-baked in there that you can drag into a workflow. And to race ahead, what's the value of all this? Everybody's been talking about big data for years, but people have a hard time actually finding the big data. Only a few companies really have it. And people went and hired all these Hadoop people because they heard they need Hadoop to look at big data. Well, this machine learning is going to give you these algorithms out of the box to sift through a lot of big data for anomaly detection or for predictive failure analytics. I can tell you, when I talk to customers about our IoT stack, this is the number one thing that really gets them going, is when you talk about predictive failure analytics. So imagine, I have a illustration of this at the end, but I'll kind of talk you through it right now. Imagine like one of the escalators that you have right here in the convention center. So imagine it was a fully instrumented escalator, all the moving parts, everything about it, and it has sensors built into it. And it's sending, maybe once a minute, whatever, it's sending telemetry through our system about the current state of those moving parts every minute. It's going in. And prior to that, you went into machine learning, and we even have a site called the Machine Learning Cheat Sheet, which is great for people like me, to make it easy for you to know what the drag and drop thing is. And so it's modeling the perfect state of that escalator and all its moving parts, ball bearings, everything, right? And then it's also detecting the changes over time from the telemetry coming in. And then the key takeaway here is that machine learning is going to go, hey, in 5 days, this escalator is going to fail. Some part's going to wear out. It's going to grind to a halt. Your customers are going to tell you it failed. That's probably what will happen. Or someone might get hurt. Or you have downtime. So apply this to every kind of machinery in the world. Everything that has moving parts that you know is going to wear out, just like the brake pads on your car. And you know the value of fixing something before it fails. Back to brake pads, right? When it's squeaking, fix it then before the rotors grind down, and how much more expensive that is. When I talk to different customers, they tell me all kinds of things where it's like, wow, when this fails, people get injured in our factory. It's scary. This is going to save us millions. This is awesome stuff. So definitely take a look at machine learning. If you are a Hadoop customer and you like working with Hadoop, we make it easy to use that in Azure. You can spin up a Hadoop cluster just in a few minutes. We make it real easy. We are totally Switzerland, by the way, on this whole Azure IoT thing. If you want to use other technologies and plug it in, you can absolutely do that. We have first-party offerings to let you do this stuff, but you can absolutely use whatever you want to use. And so we've taken lots of the great open source technology that does similar things out there and made it available in Azure so you can spin it up and you can absolutely use it because maybe you already have familiarity with it. So Apache Storm, for instance, would be a competitor to our Stream Analytics. It uses a different programming language instead of SQL to do it. Apache Spark is a newer product that's all running in RAM, and its claim to fame is it's between 10 and 100 times faster doing MapReduce, system functions, than Hadoop does. So it's pretty amazing. It does a lot of other things too. So if you have familiar with there, absolutely you can use Azure for that. When you think about outputs, the dashboards, let me see what the data is. We've got Power BI. You saw a lot of stuff talking about Power BI last night in the keynote. Just total self-service analytic tool, real simple to connect to all these data source. So stream analytics, machine learning, it can output to Power BI so that you can have a visualization, real-time visualizations of what's going on in your systems. And what, and it's anybody, I mean, there's literally, I think it's powerbi.com. You can go out there and try it for free. It's really super simple to use. So now I've got about 12 minutes left. So this is going to be kind of like a scenario lightning round. So the last part of this mashup, we have the things. We are inputting data, we're analyzing it, so now we need that output. I need to take advantage of the output of all this insight. I need to turn insight into action. And so this is where Azure App Services comes into play, and as well as things like Power BI. So you already know what web apps are, whether it's ASP.NET, websites, or PHP, or Node, or whatever. Again, we work with any kind of web framework that you want to use, and it's scalable all over the globe. You saw those data centers. We actually have something called Traffic Manager that you can enable, and those websites, when your customer, wherever they are in the world, it'll detect where they're coming from and send them to the closest data center instead of sending them the long way. So instead of sending them to my ridiculous data center in Eastern Washington, over undersea cables, it'll go, oh, no, I'm going to send them to Australia instead, or Singapore, because it's a lot closer and it'll be faster. Logic apps is a new thing, where you're not writing code. It's like triggers and workflows, kind of biz-talky work. And it's a visual designer, again, that you do in Azure, and you just piece these things together and can build logic, kind of triggered-based workflows, and then will connect to other SaaS apps. If you need to have outputs of this, maybe go into Salesforce or something like that, or Dynamics. It makes it easy for that. API apps, RESTful web APIs. We're in an API economy these days, so we make it easy to build RESTful APIs, REST JSON, using OAuth, and security, authenticating with Azure AD. Awesome stuff. And then mobile apps. If you worked with Azure mobile services in the past, that's what this is. And so we, again, make it easy to authenticate. We have data sync, like the data that my outputs maybe went into Azure SQL database, and then it can data sync, so every mobile device, whether it's Windows or iOS or Android, we took a dependency on SQLite because it runs on all those platforms by default. And so it can do data sync with those. And basically the whole gist of it is to accelerate mobile development against back-end systems. So I'm going to walk you through using all this, kind of mashing all this technology just to kind of get the wheels turning. We got about 9 minutes left. I'm just going to walk through some simple scenarios that you can think about and how you might use this. So if in a healthcare scenario, you can imagine a patient with all kinds of telemetry. And that's not something, we're doing that today. Vital signs. And you can imagine sending all those vital signs into Event Hub from all your patients, and then Stream Analytics is pulling out. In this case, it's a simple thing. Obviously, 100 degrees doesn't make any sense at all here in New Zealand. I guess it makes no sense anywhere in the world except for America. Sorry. Anyway, that would be really hot. That person's burning alive. In fact, they are on fire. Anyway, the Stream Analytics or Event Processor host would say, oh my God, I think this person's actually on fire. They don't just have a fever. We need to do something. And then we have these things called Azure Notification Hubs, which has been part of mobile services. But now that we're doing app services, everybody, all those different types of frameworks get to take advantage of all the same stuff. So Notification Hubs is this great single API call that is an abstraction. You know how you get a push notification on your phone to your apps or things like that? We've abstracted ours, Google's, Apple's push notification system. So Stream Analytics goes, on fire, calls Notification Hubs, does a push notification. Maybe there's wow, we're losing power, aren't we? And maybe you have a nurse's station using web apps, and it's streaming stuff, maybe even using real-time stuff with SignalR. And so you notify, and you've got the kind of the Power BI dashboard, but also the push notification can signal an emergency either to a nurse's station, to a screen, or maybe to a tablet to go do something. Let's talk about vending machines, since I know too much about vending machines. IoT merchandising, there's all kinds of, so I'm sending all this telemetry from vending machines, how much inventory, sales, all that kind of stuff. Stream Analytics is pulling it out, but here's where it gets interesting. It starts to notice, let's say you own 10,000 vending machines around Auckland and all these skyscrapers and all the different floors, and you just fill them with products that you heard everybody likes, but you don't really know because you're throwing darts at a board. So you put all the national brands of cookies, chips, biscuits, whatever they are here, and Snickers, and you put that. But then you discover something you wouldn't have known otherwise because you have this real-time telemetry. Wow, people on the third floor of this particular building, maybe right here in this building, seem to love those little white powdered donuts more. And you can see that in real time happening. And so you just do the obvious thing. You push notification out to your person who does the route delivery, and you tell them, hey, let's, how those candy machines have little spirals that spin to push the stuff out? Well, let's put 3 spirals worth of white donuts. And so you do that, and this is just common sense. And now all of a sudden you're making more money. I love this stuff because, so much when I talk about IoT, it's always about saving money or preventing this or helping customer experience and all that, which is awesome. But people really light up when they tell them you're going to make more money because of IoT. That's awesome. I like to make more money. So this is a quick through merchandising. So predictive failure analytics, kind of like I walked through with the escalator. Now in this case, it's just a scenario, these oil drilling out in a remote place, and they're sending their telemetry. And they're probably using a field gateway because they're so remote. And they're probably using this cool new LoRaWAN technology and daisy chaining stuff to get from their out in the middle of nowhere area back to the cloud. And then you're using machine learning and doing predictive failure analytics, all about the different components of the drilling, the wellhead, all that kind of stuff. Again, it could be anything. And determine when it's going to fail. And then it calls a push notification through notification hubs. And then boom, a repair person is notified on their Surface or their iPad or their whatever. And then they can go fix it. So you don't have downtime. So you're not losing money. So you're always making as much money as you can make. Increasing revenue, again. So we got our vending machine. It's sending all that same information. But this time you're saying, you know what? I really want to, you ever hear people talking about applying the Uber model to every kind of thing on the planet? Basically matchmaking. Uber is like, yeah, I got a car and a spare seat, and you need a ride somewhere. So I'm going to put you two together, and we're making money, and you're getting to where you want to go. So imagine Uberizing this deal. I'm sending that telemetry, and it's got the GPS location. But you did something that you never thought a vending company would do. You decide to build an app because I think the biggest value right now as we move forward, especially in the enterprise and then reaching your customers with mobile apps, is how they're going to mash up with IoT to deliver value. So your IoT device is the vending machine, but your customer has an app, and the customer has preferences, contextual information. So the customer says, yeah, I really love those white donuts, and I'm walking by, and there's a satellite GPS, and it knows that I'm nearby, and my vending machine has what I want, and it says, hey, I know it's got those Snickers. And so we do that matchmaking like you do in Uber, but with a vending machine, and then it results in a sale. So this is all good. Here's a smart city scenario. So, believe it or not, you can bury these little sensors underneath the concrete or asphalt in a city street. So in this case, a scenario here, it's for parking. I want to make it easier for the citizens of my city to find parking spots on the streets instead of them searching and driving around forever to find a spot. So I embed these sensors under the concrete, and they detect, it's just a Boolean value. Is there a heavy metal object above me or not? That's it. And then they use that cool 6-low-pan mesh technology that can go about 40 feet, and they daisy chain around, and then there's a street post, and it has a field gateway. Remember I talked about a field gateway. Maybe you'll build a field gateway yourself with one of these. And that field gateway might be using cellular. Maybe it uses LTE, who knows? And they all daisy chain and connect to that, and then it connects to the cellular network to get back to Azure, right? And so it's sending the data about what spots are available and which ones are not. And then it uses notification hubs and maps. And so now on the output side, you built an app, a mapping app maybe, that's either running on a tablet or maybe it's an in-dash car app. I know we keep waiting for all that to happen, right? We're all going to be building apps for cars. I know we've been talking about that for years. But this is a real thing. And so all of a sudden now the car sees it, maybe it's on their navigation, sat nav. And now they can see the parking spot, and it's like blinking, and it's available, and it says, go here, follow this direction, I'm going to take you to the vacant spot. It's really that simple, and it's a mashup of mobile and mapping and Azure and things and GPS, and it's all really doable now. And using these low-power wireless technologies, that thing you put under the concrete can last for 3 years on a battery. Beacons, we talked about beacons before. Again, this is another matchmaking scenario. People, we've all seen Minority Report years ago with Tom Cruise. I hear people all the time, how do I make that Minority Report thing real in real-time? So when I'm walking by, I see myself on the screen. Hey, Rob, buy some jeans. So beacons, my vending machine now has beacons, and it's sending an advertisement. And I have a beacon-aware phone and the beacon-aware app, and it sends out an advertisement that's basically doing the matchmaking thing again. Basically knows my preferences. The beacon basically is like, yes, I'm a vending machine here, and you're going to do just like you've built in a lot of systems. You just do a quick database lookup. And basically, the beacon says, yep, I know what this person wants. I have what this person wants. I'm sending a beacon advertisement, and it's going to pop up on your screen because you opted in, not because you're being spammed. And it's going to make an offer to you. And it's going to say, hey, boop, on your phone, I've got those white donuts you love. They're right here. Oh, and if you buy them now, it's going to be 50 cents off or something like that. Apply that to anything in retail. That's why retail is going crazy over beacons. Come into McDonald's to get a Happy Meal for 20% off, whatever. That's the key takeaway there. So as we crash land into the end of this hour here, that's kind of, to wrap it all up, we've got all these devices and assets, whether it's our devices, whether it's anyone else's devices, getting that telemetry in through gateways into Event Hub, analyzing it with either our analytics tools like Stream or machine learning, or anyone else's, Hadoop, Spark, stuff like that. And then the output, the insights. I find the value, I get the insights, and then I take action with it. Whether it's a dashboard showing me, whether it's push notifications to my mobile devices, whatever, so I can close the loop. And I think this end-to-end story is the why we're doing IoT, and it's not just another fad. Thank you so much for your time.